Hi again, Percy.
Hi,
How are you?
I'm fine.
Okay. So the place that you went today, your mother told me, it's called Yingi.
Ingy.
Ingi. Is
I
that
don't know
right?
what.
How-
I don't
how-
know.
You don't know?
Yes, I don't know where's Ingy.
Okay, but your mother told me it's spelled in English like this, Yingi district.
Oh, Ingy.
Ingi. Yeah.
Ingy.
Okay.
英哥，很像英哥。
So have you eaten dinner yet, Percy?
Yes,
Yeah? What did you have?
but I didn't done it yet.
You didn't done it yet.
Yes, I didn't eat my dinner down.
Okay, wait, hold on, Percy. Did you eat your dinner or not?
I have.
You have?
Yes,
You've eaten it already.
yes, but I didn't eat it all up.
Oh, you didn't finish it all.
Yes.
What did you eat?
Meatball.
Meatballs. Yummy. Was it good?
Yes.
Yeah?
Yes,
Okay.
it is.
Your mommy made it?
No.
Your daddy made it?
The caretaker made it.
Ah, your caretaker made it. I love meatballs. Okay, so we've been talking about thermal energy, and we looked at different ways to produce thermal energy, so friction, burning, adding chemicals together, and bacteria, compost. And we talked about different ways that we can use, or different ways that we do use thermal energy. Let's review that quickly. So
Melt the glass to make horse.
That's right. We can use it for art, to make pieces of art with glass. So melting glass. As we said, we can use it for cooking, melting glass. We can use it in factories to make. Yes, to make clay. What else can we use it for?
And also make the metal fence.
To make metal, that's right. To make metal into different shapes, right?
Like this book's like the castle sword.
What castle is that?
Like the castle weapon.
Which castle weapon is that, Percy? Can you show it to me?
Let me find. Like those castle weapons.
Right. That's how they made the weapons and the armor, right?
Yes.
So they had to heat the metal to change it into that shape, right? Using thermal energy. What are some other ways that we use thermal energy? Can you think of any other ways? So any way that we use heat.
Melt plastic.
Melt plastic?
Yes.
We shouldn't melt plastic. It's not good for the environment. We should try not to. But there are many ways that we use thermal energy every day in our lives, like for cooking. How else do we use thermal energy every day?
I use the sun to let the plants have sunlight.
Exactly. We use the sun. We put our plants in the sun to help them grow. That's one use of thermal energy. Very good thinking, Percy. What other ways do we use thermal energy? How about in our homes?
Fight.
What's that?
We will use thermal energy to fight.
To fight?
Yes.
To fight? To fire the
cannon.
Yeah, we can use. You definitely need thermal energy to light up a cannon, but I hope you don't do this every day at your home.
We won't.
No, we won't. How do we use thermal energy every day at our home? So one reason is cooking. Lights. Light.
And the car.
That's right.
The car and the air conditioner.
Mm-hmm. So electricity can produce thermal energy too, can't it?
Yes, and my lamp.
Mm-hmm. This is electric thermal energy.
Yes, and the computer.
Yeah, all powered by thermal energy. We need that heat. What other ways do we use thermal energy day to day?
Use the lighter to light up the stove because our stove is on.
Mm-hmm. So you have to light the stove with a lighter. This is burning. Yes. Yeah.
Because our stove is broken stove.
Mm-hmm. Your stove is broken, is it?
Yes.
And we also use it. What about if you want to have a hot shower? If we didn't have thermal energy, we would have no hot showers. We would be cold showers.
Go shower.
And does your mummy ever use a hair dryer?
Yes, we need a hair dryer.
What does a hair dryer use to dry the hair?
Hot air.
That's right. Thermal energy once again, right?
Yes.
So thermal energy is very important for us today. We use it all the time, don't we? Let's have a look at page F43 now. Can you see that page?
Yes.
Okay.
There's a house and lots of trees.
Yeah, let's have a look at that house. So a warm home lets you enjoy the snow.
The warm home let you enjoy the snow.
Good. So that house is in a very cold place, isn't it? There's lots of snow. We want lots of thermal energy in that house to keep us warm. Maybe they have a fireplace to keep the house warm. My mummy and my daddy have a fireplace in their house. They use that to create thermal energy when it's very cold in Australia. Okay, so let's read the summary. This is the summary of all that we have learned. Can you see the summary?
There's a lot of words.
Oh, the summary is short. We have a short summary, then we have some review questions. Let's read the summary first. Energy is the ability to cause matter to change. Thermal energy is the energy that moves the particles inside matter. Thermal energy that moves from one thing to another, such as left hand to right, is called heat. Okay, reading together. Energy is the ability to cause matter to change.
Energy is the ability to change.
To cause matter to change.
To cause matter to change.
Thermal energy is the energy
Thermal energy is the energy
that moves the particles
that moves the particles
inside matter. Inside matter.
Inside matter.
Thermal energy that moves from one thing to another.
Thermal energy
That moves
something to another.
From one thing to another is called heat.
Heat.
All right. So down below, review questions.
Do we need thermal energy to hold our pen and draw?
Well, not really. Not to hold a pen, I think. But when you write with a pencil on a piece of paper, it will cause some friction, won't it? Which will give off... Yeah, it will. Yeah, so writing will cause thermal energy in the pen at the tip of the pencil and on the paper.
Yes. Well, we have thermal energy when we are waving our hand in the air because we are rubbing with the air.
Well, not really. Remember, to make friction, to make thermal energy from friction, we need two solids, like our left hand and our right hand. But the air is a gas.
Yeah.
So going like this does not create thermal energy. It blows the thermal energy away. Like, think about how you use a fan in the hot weather, right? To fan yourself. This is to get cooler, to blow that thermal energy away, right? So moving our hand through the air does not create friction.
I can do air like this.
That will cause thermal energy in your muscles. Exercise, yes, from the friction of your muscles moving against the other muscles and the bones. That's why when we exercise, we get very hot. Oh. We create thermal energy inside our bodies.
Yes.
Okay, review questions. Number 1, how can you... Sorry?
Do we need thermal energy to heat up our heart?
Our heart?
Yes.
Well, we always need thermal energy in our body. If you touch your neck or your cheeks, they're hot, aren't they?
Yes.
So we do always need some thermal energy inside all parts of our body. That's why remember when we pressed our hands together without rubbing them, we can still feel some heat, can't we?
Yes.
So our bodies produce thermal energy inside them. You're right. If we get too cold, what happens? We will freeze, exactly. So we need thermal energy in our bodies. That's right, Percy. Okay, so question 1, how can you use thermal energy? We just talked about this. Let's look at question 2. What does thermal energy do to matter?
Heat up.
It heats up the matter. That's what thermal energy is. It's the heat. But what does it do to the particles in the matter?
Move it.
Exactly right. It moves those particles.
And melt it.
Well, it can melt it. You need a lot of thermal energy to melt something, though. And remember, everything melts differently. For example, ice will melt very quickly.
Yes.
Glass will melt faster than metal. And
it also melts faster than igneous rock.
Oh yeah, igneous rock is very, very hard to melt. The hardest rock that there is. And we can also, of course, melt metal, but that takes a lot of thermal energy, right? So thermal energy moves the particles in matter. Okay, number 3, name 2 ways thermal energy can be made.
Rub our hands.
Okay, rubbing our hands. What's that called?
Friction.
Okay, friction. One more.
And one is gas.
Gas? We can, but we didn't learn about that. What were some of the other ways we learned about? Friction.
Rubbing the penny with the paper.
That's still friction. Remember, friction is when 2 things rub together. It could be our hands. It could be a penny and some paper. It could be anything. If you rub 2 solids together, you'll get some friction. But other ways we can make thermal energy, remember, are burning, adding chemicals together, and making compost.
And turning my globe. It's also friction.
It does cause some friction. Hopefully not too much, otherwise your globe will melt. So you don't want too much. You don't want very much thermal energy in your globe. That's more physics, but this is chemistry. Okay, so number 4, critical thinking. Why do we need thermal energy?
Because we need a hot shower or a hot spring.
Why do we need these things?
If we don't have these things, we will cold up.
Right, because our bodies are hot. Exactly. That's a great answer, Percy. Because we are warm-blooded animals, we live in the heat. We need the heat. We need thermal energy to survive. Right?
Yes.
Okay, excellent critical thinking. Okay, number 5, test prep. Which is a good definition of heat? We have 4 different options here, A, B, C, and D. Let me read them to you. A, ice melting. B, thermal energy that moves. C, fire. D, the energy that moves the particles in matter. Which one is a good definition of heat, do you think?
Melting metal.
Which one? A, B, C, or D? A, ice melting. B, thermal energy that moves. Ice melting. I don't think this is not a definition of heat. This is a result of heat, right? First,
big the air to have exhaust.
Yeah, this is what we use heat for. But here we want to talk about the definition. So the definition, the meaning.
That's metal.
In other words, the question number 5 asks us, what is a good definition? So this means, what is heat? Is heat ice melting? No, that is a result of heat. But what is heat itself? It's not A, ice melting. Is it B, thermal energy that moves, C, fire, or D, the energy that moves the particles in matter? C and B, close. Thermal energy that moves, well, if we think about thermal energy, that is heat. So that's moving heat, not a definition of heat. And fire is only one type of thermal energy. So that's not a definition of thermal energy either. The definition of thermal energy is letter D.
D.
Yeah, the energy that moves the particles in matter. This is what heat is, right?
Yes.
Heat is energy that moves particles. Okay, let's have a look at the links. Can you see the links on the right-hand side?
But it won't move my battery.
Well, no, it won't move. It won't move that. But you know what it will move?
It will make it hot. It will make it stronger.
Yeah, that's because it moves the particles inside the clay, right? Remember, everything is made up of tiny, tiny little particles that are always moving. Sometimes they're moving a little bit. Sometimes they're moving a lot. Yeah?
And like this brush.
That brush looks pretty still. So there's not much thermal energy in there. The particles are only moving a tiny little bit. But if you, say, light your stove with a lighter, boom, you create thermal energy. Yeah?
Yes, like this tissue.
The tissue?
Yes, like burning on the tissue.
If you burnt a tissue, that would create thermal energy. But don't burn a tissue, okay, Percy? Okay, let's have a look at the links.
Tissue burning out, just throw it into the toilet.
Yeah, tissues you throw in the bin. We don't burn them. Okay, so math link. Find elapsed time. A pie Find elapsed time.
Find elapsed time.
So do you know what that means, elapsed time?
I don't know.
Elapsed time means time that has gone past. So the time has elapsed, it's finished, it's gone past. Yeah.
Like Romans?
Yep, exactly. Like yesterday is elapsed time as well.
Is alien elapsed time?
We don't know yet. Maybe they're still out there right now. Okay, so a pie has to bake at 425 degrees F for 15 minutes. Then it has to bake at 350 degrees F for 45 minutes. What is the difference between the two temperatures?
One is hotter and one is colder.
Exactly. Which is the hotter one?
5-1.
425. Do you know what the F stands for here, Percy?
I don't know.
So when we see degrees F, it means it stands for the word Fahrenheit. Can you see that? Can you say Fahrenheit?
Fahrenheit. Why? Why we don't just say Fahrenheit?
We do just say Fahrenheit. Let's practice reading that, saying Fahrenheit. After me, Percy. A pie has to bake at.
The time have to bake at.
A pie. A pie has to bake at.
The time have to.
Pie.
Pie have to bake by.
425 degrees Fahrenheit.
4,000.
425
Fahrenheit.
Degrees.
I have a degrees. I have a question.
What's your question?
But I a bit forgot.
Let's try that one more time. If you remember your question, you can ask me. 425 degrees Fahrenheit.
What is Fahrenheit?
Fahrenheit is a way that we measure temperature. It's the American way. Now, in Australia, we use a different way, and this is called Celsius. So
I know.
yeah, sometimes you will see heat or temperature or thermal energy measured in Fahrenheit or Celsius. They're just
I know.
two different ways of measuring thermal energy. Do you understand that?
Now I understand.
Okay, so for 15 minutes,
For 15 minutes.
then it has to bake at
Then it has to bake at
350 degrees Fahrenheit.
300 degrees Fahrenheit. What
Good.
are we baking?
We're baking a pie. Do you know pies?
I don't know what is a pie.
A pie. Let me show you a pie. Oh no, I can't show you because you're on the smartphone. A pie, it's a type of food that you eat. It looks like this, and it has bread on the outside.
Can't see it clearly.
Let me bring it closer. Can you see it?
Because the camera not good for me.
Let me try a darker color.
Now I see it.
That's better. So inside you can put meat. You can have a meat pie, or you could put some apple to have a sweet apple pie, right? It's a type of food. Very delicious. Okay, so that's all about cooking pies. Let's move
we
on.
need to cook so long time.
Yeah, 1 whole hour. First 15 minutes at 425 degrees, then 45 minutes at 350 degrees. It takes 1 hour to cook. Pies take a long time to cook. Let's continue reading. Okay, writing link. Now it's writing story. Write a story about David. Okay. We'll skip the writing link. We'll look at the health link. Okay? Health link.
I say health.
Keeping warm.
Keeping.
Okay, listen to this. People have used wool for centuries to keep warm. Find out 4 kinds of animals that we get wool from. Okay, your turn. People have used wool.
People have used wool
For centuries.
For centuries.
To keep warm.
To keep warm.
Find out 4 kinds of animals that we get wool from.
From the 3 animals that we get wool from. Lamb.
Okay, so do you know any animals that we get wool from, Percy?
Deer and lamb.
Which ones?
Deer and lamb.
Deers?
Yes.
No, not deers. Deers have short fur. Hi, Pearl.
And lamb.
Lamp?
Okay.
How do you
Yeah.
spell that?
The girl that has a lamb. That's the lamb. The sheep.
Sheep. Oh, lamb. Lamb. Sheep. Yes, sheep is the main animal that we get wool from. That's the number 1 animal for wool, sheep. But also, no, horses, their hair is too short. Some goats have very long hair, such as in India, the country India, and they make wool too. There's a very special type of goat called the cashmere goat. This creates a beautiful... No, not dogs. Their hair's too short. But our time is up tonight, guys. So goodbye.
Bye.